I started the recording. And Hervé, if you are ready, I'm going to switch screens and make you presenter.
Great. Thank you very much, Rachel.
Thank you. Everyone have a great session.
All right. Great. So can you see my slide?
Yes, I can see it.
Okay, perfect. Thank you. Good morning, everyone. My name is Hervé Rogero. I am a SQL Azure MVP and run a company called Blue Syntax Consulting. We specialize in consulting services, advisory services, and development on the Azure platform. We build products for the Azure platform as well, including a backup tool and a migration tool that I'm going to be showing today as well. Some of those tools are free. And you can contact me through my email at bluesyntax.net. Also on Twitter, I run a couple of LinkedIn groups, one around SQL Azure and SQL Server Security. And another one is an association that I run called the Azure Florida Association. We have Azure meetings every other month, usually. We had our first one in January. Our next one will be in March, towards the end of March. If you join the LinkedIn group, you will be able to follow the activity of that association. And my website is bluesyntax.net. So today we will talk about SQL Azure, and specifically the ability and the different options that are available to you to move data into SQL Azure. And we will compare the various techniques available against the SQLBulkCopy API that .NET offers. So we will look at that. We will compare why certain things are a little slow, what's going to be faster, and also we'll take a look a little bit at SSIS, and I'm going to show my complete ignorance in SSIS, but I managed to make it work a little bit, so we'll go through that. And that's really what this presentation is about. If you have specific questions, it's not really an introduction to SQL Azure, but if you have specific SQL Azure 101 questions, really don't hesitate. This is what this forum is about. I don't know if I can hear you, but I'll monitor the chat window to see if there are any questions coming through. So we'll talk about some of the tools available to load data today in SQL Azure. We'll talk about the insert commands. There are a couple of ways to use the insert commands. The SQL data adapter. We'll talk BCKey and see how that works. We'll talk about the SQLBulkCopy at the end, and I will present the performance tests results that I ran with the different approaches. So there are two ways to insert data, and we'll take a look at this specifically. Normally you can use the insert bulk operation, but not the bulk insert. There's actually two ways to insert data, and we will review that in more detail. Insert bulk is supported. You can use a SQL data adapter. You can use a migration wizard, which is on CodePlex. That has been used by a lot of people to migrate their databases over in the cloud. You can use SSIS to migrate your data. BCKey as well, which basically is a command line utility that uses insert bulk behind the scenes. And then the SQLBulkCopy API. And I'll talk about another tool as well that came up. So when you talk about loading data, if you have small databases, it's going to be pretty easy and pretty quick. You can use SSIS, you can use the open source CodePlex project, and you're not going to have any issues. But as soon as you start having a little bit of data, a couple of gigs of data or more, and much larger tables and large objects to transfer, you're going to start really seeing the complexities of loading data in the cloud. And normally you break down the upload time in the following dimensions. You have, of course, the connection time, and it's not trivial. There's actually some a lot of things to know about what it takes to connect to a SQL Azure database frequently. We'll review that later. You have to send a query, of course. You have to compile a query and execute the query, and then eventually send the data. So this is kind of a breakdown of what actually takes place, what takes time to load your data in the cloud. Of course, this is no different than loading to SQL Azure, but the SQL Server on a local network. But the difference is that because your database is it's a far link connection, and it's always encrypted, you may be surprised as to where you actually spend your time. So the first thing that I tried, obviously, and the reason this came about, just as a little bit of a background story here, I started to look at different ways to insert data in the cloud because I was building a backup utility called Enzo Backup that's used quite frequently now by a lot of people to back up their databases in the cloud. And obviously, as part of the backup, once you have your backup, that's nice, but then the next question is how do you restore it? So I spent quite a bit of time analyzing what were my options to restore data. And that really is where this presentation came about. So I, of course, first looked at insert statements, which is a very classic. It's a logged operation. Normally you work a single record at a time. And because all the packets are all encrypted, it's definitely a verbose operation, and it's very, very slow. So as you could expect, your standard insert statement at the bottom is what you would normally do, and you can send them in a batch and execute them. There is, since SQL Server 2008 came out, you have a new way to insert data with the insert command, which is not as verbose. You actually remove quite a bit of text, but the operation, of course, is still logged. And the technique is called a table value constructor. So you have a single insert statement, and you can actually add multiple records in that one statement. You're limited to 1,000 records. So you can then batch 1,000 records like this, and then send another 1,000 records with a single insert statement until you get to the end of your table. It's faster than your regular insert, but it's still slow. And the reason it's faster is because you have less compilation time, a smaller statement footprint that you need to send over the wire. So far, so good, and all of that is simple and makes sense. And real quick on SQL Azure. In SQL Azure, the version right now is SQL Server 2012. So, as we've seen, the insert command, you have to establish a connection, of course, and then you have to send your statement over into your SQL Azure database for every insert command. Then you have a bulk insert operation. Now, bulk insert, as I mentioned earlier, is not supported in SQL Azure. The reason is that bulk insert is a command that you send from the client, and that's the only thing that's being sent over the wire is the command. The data is already on the server in the form of files. In the case of SQL Server, that's okay because you can place your data files on the server, and from your insert, the bulk insert command, you can refer to that file and it loads it directly. In SQL Azure, you do not have access to the server. You don't have physical access to the servers, so you cannot pre-load or send that file over on the local server and then just send the statement. That doesn't work. However, the insert bulk operation is supported, and it's kind of a really cool technique. So what happens is that you're feeding raw TDS packets to SQL Azure or SQL Server when you do any insert bulk. But unfortunately, that means you need to have a specialized tool to use that command. It's a TSQL command. If you try to type insert bulk in SQL Server Management Studio, SQL Server basically turns into a mode that expects TDS packets raw to be sent to it. So you need a tool to actually send those packets. It's extremely efficient and very, very lean. You send just one insert command with the insert bulk command, and everything that follows that are raw packets that go straight into the creation of the table. There is no compilation or query execution taking place as a result. And SQL Azure basically waits until it receives a termination token that says the load is completed. The operation is not logged, which means insert bulk is pretty fast. So this is the way insert bulk works. You start the statement as you would do for bulk insert, except now you have a tool that sends the raw packets to SQL Azure. Because it does not require the file to be on the SQL Azure servers, which you do not have access to, that actually works against SQL Azure. So what's BCKey? Well, actually, BCKey leverages insert bulk. That's really what it is. It's the tool in question that allows you to send those packets over to SQL Azure or SQL Server. So the performance of BCKey is directly related to the performance of insert bulk. The advantage, however, is that BCKey is a tool that you can also use to extract data, not just insert. So it's a pretty fast command. It actually works pretty quick. SSIS and the migration wizard are tools that leverage BCKey. You have the bulk insert task in SSIS, and then the migration wizard that I mentioned earlier, this is the URL where you can get to, allows you to leverage the BCP utility behind the scenes through a tool and through a user interface and load the data. I'm going to show you SSIS later as well, where SSIS also has the ability to not just do a bulk insert, a BCP, but also straight raw packets. I'm going to show you this a little bit later. You also have in .NET, if you're creating a software like I was doing, what you need is a programmatic access to BCP, which really doesn't exist, or I didn't think existed. So I tried the SQL data adapter, which is a typical ADO.NET approach that allows you to load data in batches. Unfortunately, it's extremely memory intensive. It's all based on XML datagrams. So it takes a really large memory footprint. And depending on how you use it, it's extremely slow. But it does provide a way to work in batches. And it does send insert operations. So as you can imagine, the SQL data adapter does not deliver from a performance standpoint. And then you have the SQLBulkCopy API. The SQLBulkCopy API uses the insert bulk operation that we discussed earlier. So it gives you programmatic access to something similar to what BCP does in .NET. And you can also send data in batch. And because it's the equivalent of using BCP and it uses the insert bulk operation behind the scenes, it's fast, or faster, right? So here's a quick summary of techniques that you can use and what the operations that they use behind the scenes. As you can see, the insert operation or the data adapter that uses insert as well, both of those are logged and they're really slow. And the other methods and techniques outside of bulk insert, which is not supported, is insert bulk, BCP, SSIS, and SQLBulkCopy. So I ran a performance test, and I wanted to know how do they compare by how fast is fast and how slow is slow. So I decided to try on 40,000 records. That's not a whole lot of records, but it allows me to do a whole lot of testing because it's pretty fast. So I ran that test and transferred 40,000 records from an on-premise SQL Server database to a SQL Azure database. I used multi-threaded operations on 8 threads using the task parallel library, the TPL, which is a library available for .NET 4.0, which allows you to send commands in parallel to execute commands in parallel. So in this particular case, I was loading data with 8 threads. And I compared the data adapter. A store proc, I wanted to see how sending a command through a store proc would behave because that reduces compilation. The insert statements and the SQLBulkCopy API. And this is basically what came out of it. The degree of parallelism here is 8, right? I have 8 threads running, 40,000 records being loaded. On the x-axis, what you have is the batch size. I wanted to figure out if there was going to be a big difference in data load depending on the size of the batch. And my load time in seconds is on the y-axis. So real quick, let's take a look at that graph. The data adapter, as you can imagine, is the slowest, and was taking more or less 30 seconds on average to load 40,000 records, and it's pretty slow. I mean, imagine if you've got millions of records, that's going to take a while. Then the store proc approach was surprisingly fast, outside of a weird glitch that I kept getting in 150 to 200 range batch size that was really slow. The store proc actually behaved pretty good between 10 and 15 seconds consistently at higher batch sizes. The SQL bulk copy API is that dotted line at the bottom, and as soon as you have more than 500 records at a time that you're sending over the wire, you have a near constant speed, and it was basically oscillating around 2 to 3 seconds to load 40,000 records. So that's really, really good. And the insert 2 here is the table value constructor approach, where you use the new insert command from SQL Server 2008. I wanted to see how that behaved. And you can see that you can actually, it's not too bad. It beats the store proc approach, and but of course you're limited to a batch size of 1,000. So but it was still pretty good, I thought, better than I expected. So let me drive you through the test actually, and the code I'm showing you here today I can make available. I'm not sure, Rachel, how you want to do this, but the project I have and I'm going to show is something that I can provide a link to online to download.
Oh, that'd be great. If you have a personal blog, or if you'd like to send it to me, I can post it as well.
Yeah, you know what? I'll do that. I'll probably do a blog post, and I'll send you the announcement when the blog is ready.
Oh, that sounds great. Thank you.
Okay. So it's a simple program, and which means it can be improved if you read between the lines. I have different methods here. It's a flat program. There's nothing else. You have all the methods are here, and you call the program by either calling one of those things, which is either execute with SQLBulkCopy, execute with proc, execute with inline SQL, with a data adapter. These are your choices. And if you look at, let's take a look, for example, with the data adapter. The way the program works is that it starts by truncating a table. It assumes a specific schema for a table called T1, and the schema is provided on top. This is what you need to run in your SQL Azure database for this to work. and also create the store proc if you actually intend to use the store proc call. So back to our data adapter approach. So I truncate the table first. That doesn't count in my overall timer. I create a collection of rows and basically go down, and I use the task parallel library here called Parallel. It's in a namespace is system.threading.task parallel, allowing you to execute a specific segment of code using a specific degree of parallelism. So here I have 8, which is what I'm setting up as my option. So this is going to run with 8 threads, and I'm going to run this 8 times in parallel for all the data that I have. So I first build the data on top, and as soon as I'm ready to start, then I initiate my stopwatch and create my data adapter, create the insert command, and basically go through the process of updating my rows. Because the rows are not in the destination database, it actually creates an insert statement for you, and that's really how this works. And for every batch, I basically output a debug line that tells me how long it took to execute that specific command. And then at the end, I give you the total execution time and the average. All the other methods are similar. So if you take a look at, let's say this is the SQLBulkCopy command. I truncate my table again. I create my data. I have a method here called build data table, which in memory creates a data table with my data. I set again the parallel options to my degree of parallelism, and I basically execute my SQLBulkCopy command. So bulkcopy here has a connection string. I set a batch size to 0, which is set everything that I have defined in my data table here, which is already batched. And I basically write to server, which is the command that will connect to the server, send all the records with whatever batch size you specify here, and send the raw packets, and basically close the connection here. Make sure you close your connections. That's really important. Otherwise, your tests are not valid. So let me show you real quick how this works. I'm going to bring a window here, which is my SQL Azure database. I created a database yesterday called TestDB, and this is my table, T1. Right now I have some data in there, so let me truncate the table. So at this point I have nothing else. You're here, and this is SQL Azure, right? I think I said that. So my test is ready to be executed. I'm going to run, let's say, the data adapter approach, and each method takes a number of parameters. So I want a number of items in a batch. I want to send 1,000 items 40 times, so that's 40,000 records with a specific degree of parallelism, and I'm going to put 8. So that's my test, and when I execute the test, in theory, it tells you how long it takes to insert those records, and every command here, basically every batch takes 3+ seconds. And you can, this is only 40,000 records. It took about 24 seconds total, 25 seconds with an average of 3.5. If I execute the same using the SQLBulkCopy API, let's say a batch of 1,000, 40 times with 8 threads in parallel, you're going to see the difference. poof, 3.5 seconds to load 40,000 records. So this little program doesn't do a whole lot, but it really helps you play with assumptions, with batch sizes, with a degree of parallelism and your threads, and kind of tell you what you can expect from your response time standpoint to SQL Azure. I think that's pretty much what I wanted to show with this particular program. And again, if you want that tool, then we'll make, we can definitely make it available. So the next thing I wanted to talk about, and oh, by the way, at this point, I ran this twice. Yeah, so yeah, that's right. I run a truncate command at the beginning, so I always have 40,000 records in the end. All right, so I did not talk about a product I released a couple of weeks ago called the Enzo DataCopy. It's in beta. It's a free tool, and I'm going to talk to you about this a little bit and compare that to SSIS. But first, here are the comparing the tools between SSIS for 40,000 records. It took about 4.2 seconds. The SQLBulkCopy was extremely fast, 2.18 seconds, and the Enzo DataCopy is 25 seconds, right? So obviously, for 40,000 records, the little tool I wrote does not make sense because that's really too small. It's too small of a database, and so you could actually ask if your question is, why do you bother writing a tool if it takes 5 times longer? And the reason is when it comes to higher loads. I'm showing here the result for 2 million records, and this is now in minutes. SSIS will take about 2 minutes and 18 seconds, 17 seconds. The SQLBulkCopy API will take over 4 minutes. And the tool I'm going to show you as well took less than 2 minutes, 1.4. And this actually has to come, a lot of things go behind the scenes in optimizing your writes to SQL Azure. Choosing the technique and choosing the API is the first step. The second step is actually how do you optimize it and how do you make it work as fast as you can for you. Now I'm going to have a disclaimer here. I am not an SSIS expert. Is it possible to drive SSIS to faster load times? I'm sure. I'm sure there's a way. But nevertheless, this is what I did. So all I did, if you've never done this, it's trivial. Again, as I said, I'm not an SSIS person, and I was able to figure this out in 3 minutes. I created my connections at the bottom. So I've got my connection to the cloud, which you can see here. This is my server name, which is really a DNS entry in the cloud. My password, just about everything is here. And this is my local SQL Server connection, which points to a local table. So what I'm doing is I'm basically copying data from my source, which is table T1 that I have here on my local instance, to the T1 table in the cloud. And all I did was basically to drag that arrow here and basically execute the command. Right? So if you do that, at this point I have an empty table. I should be able to run it last time. There you go. To execute that task, looks like I have a problem. Demos. That's actually working. It's really slow, and I'm wondering it's because I might have changed the use bulk insert when possible. It's set to false. I think that's the issue. So it's loading the data, but as you can see, it's taking forever because it's not using the bulk approach at this point. It's probably just inserting records one at a time. There is no way to trace right now the commands that are taking place in your SQL Azure database. The SQL trace is not available. So you can't really sniff what's going on necessarily. You can look at system tables and figure that out. But that's likely what's happening here. It's loading the records in batches using an insert command. And you can see that it took a minute and 10 seconds. It's pretty slow. So let's try that again. And I'm going to change this to yes. My 40,000 records are here, so let me truncate it and execute that again. That's a little bit faster. Quite a bit, actually. So that's to show you that SSIS, even with a straight data transfer, is able to use the insert bulk command if you tell it to do so. And by default, it's checked. So it was me yesterday, and I was just playing with that option. And that took 5 seconds. So that's really about as much as I was going to share with SSIS. What I want to do as well is actually, I'm going to drop it. I'm going to show you, this is the wizard I built, which allows you to transfer, again, it's free of charge. It allows you to, the purpose here of that tool is not to synchronize data. It really is to migrate a database from your local environment to the cloud. So it's assuming that the tables don't exist in the destination, which is why I dropped it. I provide my connection string here. It's giving me a warning, which there's a little bug I'm fixing. And here you can choose, which table you want to transfer. So I'm going to you can either transfer all the objects or specific tables only, and with indexes or not, right? So in this particular case, I'm just reading from my, sending over the T1 table from the DBO schema, and sending that over. So what it does is it's going to analyze the selected objects, and here it tells me that there are no specific issues, that it should migrate just fine. And that's basically the screen that allows you to start the copy operation. And I'm going to tell you why it's so slow when you have a small table. The difference between this tool and the others is that it actually extracts the data in parallel on your local drive. So it actually creates really the equivalent of temporary files on your local directory structure, and then it loads them. The process is such that the more files and the bigger the database, the more efficient this becomes, because you can actually control a lot of settings as it relates to how you want this to work. So for example, you can tell it to use 8 threads when you import the data, but you can actually go much higher and say 64 threads. This will force 64 threads, even if normally the task parallel library, or the TPL, when you tell it that you want to use 64 threads, it's actually telling you that it's going to use up to 64 threads. But the TPL remains in control of how many threads are actually started. In this particular tool, what I'm doing is I'm forcing 64 threads. And the reason is that the latency with SQL Azure is such that you can run many threads in parallel without, far more than you have CPUs, because there is such latency with the data. So forcing 64 threads here is what allowed me to operate faster than SSIS on a much larger table. You can control your export and import batch sizes as well, which is kind of handy. And and then, you know, these are kind of the performance options that you have on that tool that allows you to control your load operations. Check it out. Okay. So we did the demo here on this on the tools on SSIS, the Azure DataCopy. If you're interested in that tool, go on bluesyntax.net. You can find it there. If there's one more thing I'd like to talk about, is as it relates to connection issues or performance issues that you may be facing with SQL Azure. All we've done so far were really simple loads, simple data transfers, very short time span of operation. If you're dealing with larger databases, I'm talking about 2, 3, 5, 10, 50 gig databases, transferring data will take time. You will be transferring time over a few hours, potentially. So at that point, you're starting to get into a different realm. This is where SQL Azure is nowhere near SQL Server. This is where understanding what SQL Azure is good at, what it offers, and what are its limitations becomes really, really important. And this is why the CodePlex tool, and this is why SSIS becomes much more difficult to use on very large databases, is due to the fact that SQL Azure behaves differently under load. It behaves differently under stress than SQL Server. So that the first concept is related to throttling. Throttling is a mechanism that is implemented on SQL Azure to keep you from creating performance issues on the server. So if you have really high I/O conditions, if you have really high memory conditions, or you're issuing way too many locks that could actually impact the other customers on the same server, your connection will be dropped. So understanding what those conditions are, what those limitations are, is fundamental. And the tool I built, and which is based on the backup tool I created last year, actually understands those errors, or most of those errors, and will change its behavior, its load behavior, depending on some of those errors. And that's fundamental because it allows you to eventually complete the operation. The other tools are not built that way, which means if it breaks, you have to start all over. So something else that you have to do and consider is connection retries as a result. Because of throttling conditions, but because also of other issues, such as dynamic load balancing taking place in the Azure world, such as network drops and network issues, that at any point in time, something could happen while you connect to the internet. You may lose connection or packets for a split second. Building a resilient load system is extremely important, and that's why I built these tools. I'm going to show you here real quick what I'm talking about. It has to do with understanding those errors, and I'm going to load that URL here. I really want to spend a couple of minutes on this because that's fundamental. You can get going real quick, but if you start dealing with large environments and large systems, you really need to understand this. So at a high level, this is how the architecture of SQL Azure is put together. Your application is on top. Mind you, this could be SSIS, right? You have your connection to the cloud, which ends up on the load balancer. And behind the scenes, you actually have multiple load balancers as well that will connect you to the correct SQL server, or really SQL Azure database. So your database could be on one of those yellow boxes, but at any point in time, it could be moved to another box. It could be moved for a variety of reasons. The load balancer may be unavailable for a split second for some weird networking reason. You may have any number of reasons in here that could potentially break your connection. In addition, you have the conditions within the SQL Azure environment that I mentioned earlier, called throttling, which could also break the connection for you. So, for example, if you use too many logs, you're going to get a connection termination. Too many uncommitted transactions, that's another one. You cannot exceed 20% of the log size. 10dB is being used too much, or the size is way too large. Excessive memory usage. You've reached the maximum database size. When you create a SQL Azure database, you specify what is its size. It comes in very specific sizes: 1 gig, 5 gig, 10, 20, 30, 40, 50, 100, and 150. If you create a database of 1 gig and you're loading 1.5 gig of data, at 1 gig is going to stop working, and obviously, so that's one of the throttling conditions. Idle connections will get killed automatically within 30 minutes. Network issue, failover problems, and a load of other reasons. And sometimes, if it's throttled, you will get an error code, but you don't always get an error code if it's a reason that's outside of the control of SQL Azure directly. If you're getting disconnected because the gateway is having an issue or is moving your database, you may not get that type of error code. You may get a network I/O error of some kind. So understanding the types of error you're getting, understanding the transient nature of your database in SQL Azure is really fundamental to have a highly robust data transfer system and mechanism. So I'm going to really stress this really hard. You have some notes as well at the end, talking about what are the type of troubleshooting techniques that you can use. Because these are transient connections, these are transient errors, I should say. It means two things. One, you cannot predict when they're going to happen, or in most cases. And two, if you don't know when they're going to happen, you're going to have to really adapt in your code in retrying and resending your commands if it makes sense. If you're getting a throttling condition saying, well, your database is too small, retrying is not going to help. But if you're getting an error because the database is being moved over, then waiting a few seconds and retrying is going to help. So as far as the presentation, that's it. I wanted to cover those things with you, to talk about the different loading patterns, and what I have learned with different ways to load data in SQL Azure, and specifically the gotchas that you have with SQL Azure that you do not have with SQL Server when it comes to loading data in the cloud. I hope this was useful, and I'm definitely open to questions.
Okay, great. Yeah, that was wonderful. I actually learned quite a bit. We do have several questions. The first one is, can you also do an insert into table name? Select column list from table name 2.
I think so. You have, I don't know specifically about that particular approach, but I do believe you can. If you search for your insert statements, if you do, select SQL Azure, you will get, quite a bit of information. Select. Well, that's not what I was looking for. Let's try this. That's what I was after. You will get what is being supported and what's not supported pretty clearly. The documentation is evolving. You may find one or two errors, but for the most part, it actually works. So if you look at the select statement, so we have the partially supported operations. Which give you what you can do and what you cannot do, right? So the select into with partial columns, I believe you can, but I recommend you try. The other thing too is you cannot access. You don't have link server options, so you cannot access all the databases in the cloud. So everything that you're doing has to be, if you're issuing a SQL command within a SQL Azure database, it has to stay within that database.
Okay, well that makes sense. Our next question is, why is there a 1,000 record limit? What happens if you try to insert more than 1,000 records? And does the data size of each record become a factor with this 1,000 record limit?
So when I talked about that, I was actually referring to the insert command with the table value constructor. If you're familiar with that command, it actually builds, if I go back on that screen, if you go back to that screen here, this is the table value constructor, and Microsoft has placed a limit on how you can use that SQL command specifically. So if you use the table value constructor where you are passing basically every row here is a new record, that's the syntax since SQL Server 2008, you can only send 1,000 of these. It's the only command or technique that we have reviewed here that is limited to that 1,000 batch. And that is basically by design. This is what Microsoft has implemented. Any other tool or technique, you can actually have a batch batch sizes greater than 1,000.
Oh, okay. All right. We have another question. I want to perform ETL from my on-premise SQL Server to SQL Azure. Will this approach work?
I'm sorry, what's the question again? Repeat that. I want to perform an ETL from SQL Server to SQL Azure?
Yes.
And what's the question?
Will this approach work?
Which approach?
I think he's saying he has a SQL Server on-site, on-premise, and he's wondering if he can...
Yeah, so absolutely. So if you use, you can use, as we've discussed, you can use SSIS. It'll work just fine for ETL. And again, you will have to be careful with the performance issues that we talked about here if they apply to you. And the best thing to do this is to do your ETL with, I don't know about the other tools. I know there are many ETL tools on the market. I know SSIS can work with SQL Azure very well. I don't know about the others. I'm sure most of them do by now. So the short answer is most likely yes, depending on the tool you use. But regardless of the tool you use, if you have large databases and a lot of data to transfer, you will potentially at some point face the issues that you see here, which are related to throttling and connection retries.
Oh, okay,
which means you may have to handle that in your ETL as well, in your ETL package.
Okay. Our next question is, you said you were creating temporary files. Are you using SQLBulkCopy for doing this in the tool?
No. What I'm doing is I'm basically, I developed a technique to read tables in chunks, and I am basically at this moment I'm serializing data tables on disk. So my temporary files are actually serialized chunks of data tables. And I am using my data table, I'm deserializing the data table into memory when I restore, and that's what I feed into the SQL Azure BulkCopy is the data table.
Oh, okay, I see. Mark would like to know if you could offer any suggestions for quickly loading data from on-premise to Azure Table Store.
Azure tables. Oh. Well, as of today, I'm not aware of any utility that would allow you to do this quickly or efficiently. It's definitely something I was looking at doing myself. But I have to say that as of today, I don't know of any tools that does that.
Okay. And then we have several requests for your PowerPoint presentation. Do you have a blog or any means that you're going to be posting this on after this presentation is over?
Yeah, so what I'll do is I'll shoot a blog this afternoon.
Perfect. And then you'll send the link to me.
And I will provide the link to both the presentation and the sample solution.
Okay, wonderful. So anybody who would like a copy of this presentation can either access it directly on your blog, or they can email me, which my email is in your confirmation GoToMeeting email, and I'll send it your way. And that's
Perfect.
about it. So thank you so much, Hervé. We really enjoyed the presentation and appreciate your partnership with Pragmatic Works.
Thank you very much. And in fact, I just realized my blog is in there. So here it is.
Oh, perfect.
It's Geeks with Blogs, Edgewood Journal.
Perfect. All right. Well, once again, thank you everyone for joining us, and I hope you have a wonderful rest of the week.
Thank you very much.
Thank you.
Bye-bye.